Welcome back to World Decoder. To close this series, we look beyond handheld devices to what lies beneath the Earth's surface. We are exploring the hidden fortresses on mountain peaks and the mysterious cables resting silently on the bottom of the ocean. This is a deep analysis of the Silicon Fortresses, the massive physical structures defining the destiny of humanity in year 2026. These are the underground cities of data, the burning hearts of artificial intelligence that pulse rhythmically beneath the surface of Earth. Did you know that by February 2026, the world is operating over 10,800 active data centers globally? The United States alone hosts nearly 4,000 of these facilities, solidifying its status as the undisputed data capital of Earth. However, these are not your ordinary storage warehouses. They are sophisticated fortresses guarding the most valuable asset of the 21st century. We are witnessing the explosion of data gigafactories. In 2026, we no longer measure data centers in mere megawatts anymore. We have officially entered the era of the gigawatt data center, structures so large they rival the size of small cities. Projects like Stargate by OpenAI or Prometheus by Meta are costing hundreds of billions of dollars to construct and maintain. A single 1 gigawatt data center consumes enough electricity to power 1 million average households for a very long time. These are true monsters of consumption, where tens of thousands of next-generation GPUs are networked to create a singular intelligence. This massive network creates an artificial intelligence capable of changing the world, but it comes with a significant physical cost. The insatiable thirst for computer chips has led to an even more terrifying crisis: the desperate global thirst for electricity. In Ireland, data centers currently consume up to 32% of the total national electricity supply in the year 2026. Tech corporations are no longer just renting land. They are aggressively hunting for locations with abundant and stable power sources. They build data centers next to hydroelectric dams in Washington or near giant wind farms in the windy Nordic regions. They do this to utilize green energy and take advantage of the natural cold to cool down their overheating machines. To keep these GPU arrays from melting under heat of thousands of degrees, centers are shifting to liquid cooling solutions. Instead of using noisy air fans, chips are now immersed in special dielectric fluids or have water piped directly through. This technology silences the roar of the machines, but decoding the blood and water of the internet reveals a cost. The AI industry is expected to consume up to 1,100 million cubic meters of water annually by 2030. That staggering amount is equivalent to the total annual domestic water consumption of the entire population of a small country. Water and electricity are the lifeblood of the internet, resources that are being sacrificed to fuel our digital rapid expansion. Data has become the oil of the 21st century. In 2026, nations are tightening laws on cross-border data protection. Where you place a data center is no longer just an economic issue. It has become a critical matter of sovereignty. If a nation holds the data center containing medical, financial, and behavioral information of another country, they hold immense power. This control over sensitive information represents a terrifying form of soft power that can destabilize nations without firing a shot. As we conclude this series, remember that the internet is not just a harmless cloud floating gently in the sky. The internet is millions of tons of steel, copper, and silicon. It is cooling rivers and fiery high-voltage power lines. Behind every simple answer from AI, behind every video you stream, lies a sacrifice of natural resources and energy. It requires the ceaseless operation of the most complex mechanical wonders in history to maintain our modern digital lifestyle. The digital world might feel virtual, but the price to maintain it is incredibly real. This is the new reality. As we build these silicon fortresses higher and deeper, we must ask ourselves if the foundation is strong enough to last. Humanity is building a new nervous system for the planet, one that demands constant feeding and care to survive. The speed of construction is unprecedented, reshaping landscapes and local economies faster than any industrial revolution we have seen before. Inside these tiny chips lies the complexity of a metropolis, processing information at speeds the human brain cannot comprehend. Information flows like a river, but directing that river requires dams and canals made of code and physical infrastructure. These facilities never sleep. They hum with activity 24/7, ensuring that your connection to the world is never broken. The integration of renewable energy is crucial. yet the demand often outpaces the supply that nature can currently provide us. As artificial intelligence models grow larger, their appetite for energy grows exponentially, challenging our current power generation capabilities. We are balancing on a thin line between technological advancement and environmental preservation, a challenge for the next decade. Perhaps future innovations will allow nature and technology to coexist more harmoniously, but for now, the conflict remains intense. Liquid cooling represents a leap forward, turning the violent heat of processing into a managed, quiet flow of thermal energy. Every time you scroll, like, or share, you are sending a signal to these distant fortresses demanding them to work. The deep ocean cables connect continents, carrying the weight of global communication through the silent, crushing depths of the sea. Without this underwater web, the global internet as we know it would collapse instantly, isolating nations from one another. We are even looking to the stars, launching satellites to extend this network, but the core processing remains grounded here. Security within these facilities is tighter than most military bases, protecting the data that defines our identities and economies. From biometric scanners to armed guards, the physical security of data is taken just as seriously as its digital defense. The infrastructure is becoming modular, allowing tech giants to deploy capacity rapidly wherever power and land are available. The cloud is a brilliant marketing metaphor, but it obscures the heavy, industrial reality of the internet's physical existence. It is a landscape of concrete, steel, and noise, far removed from the airy, intangible image we often imagine. Efforts are being made to green these gray fortresses, covering roofs with solar panels and utilizing waste heat efficiently. In some regions, the heat generated by your social media scrolling is being used to warm homes during winter. Cryptocurrency mining shares this thirst for power, competing with AI for the limited electricity resources available on the grid. Diplomacy in 2026 involves negotiating fiber optic routes and data hosting agreements as much as trade deals and treaties. Digital nationalism is rising, with countries demanding that their citizens' data remain physically stored within their own borders. The hunt for efficiency drives us to the ends of the earth, turning frozen wastelands into hubs of high-tech activity. Ships patrol the oceans not just for defense, but to maintain and protect the fragile glass threads connecting humanity. From shark bites to anchors and earthquakes, the physical vulnerabilities of the internet are numerous and often completely unpredictable. Automation manages these fortresses, with robots replacing broken components faster and more accurately than any human technician could manage. The connection between ground and space is tightening, creating a seamless sphere of information surrounding our entire planet. This infrastructure exists to support the synthetic minds that are beginning to speak, think, and create alongside us. We are forging a partnership with Silicon, building a home for it that rivals the complexity of our own cities. These data centers are the libraries of the future, preserving the sum of human knowledge in magnetic and optical formats. But unlike stone libraries, these archives are fragile, dependent on a constant flow of electricity to prevent erasure. We are racing against time to make these systems sustainable before their resource consumption causes irreversible environmental damage. The solution lies in innovation, in finding ways to power our digital dreams without destroying the physical world. Future technologies like DNA storage may one day shrink these massive fortresses into the size of a sugar cube. But for now, and for the near future, we must live with the giants of steel, concrete, and silicon. The next generation will inherit this infrastructure, along with the responsibility to manage its impact on our shared planet. Our cities and our data centers are merging into one singular pulsating organism of light, energy, and information. We are walking through a tunnel of data, guided by the unseen machines that hum beneath our feet silently. The power is on, the lights are blinking, and the water is flowing. The machine is alive and hungry. Energy, water, and data. These are the three pillars supporting the roof of our modern civilization in 2026. From the highest peaks to the deepest oceans, we have stamped our digital footprint onto the physical face of Earth. World Decoder hopes this journey has revealed the hidden weight of the virtual world you navigate every single day. Always remember the final message of our series. The digital world is virtual, but the cost is very real. Thank you for joining us on this deep dive into the infrastructure that makes our modern lives possible. If you enjoyed this analysis, please share it to spread awareness about the physical reality of our digital future. We will continue to decode the hidden layers of our world in the next episode. Stay curious and aware. This is World Decoder signing off. See you next time.